Hi everyone, I'm Sushmita. As we discussed earlier about the RAG, now I'm going to show you the functionality of the RAG on the code how we can write, and I'm going to explain you the code. So this is a code of the RAG project. By using the RAG, we are doing the chatbot. So for this, I have taken these files, backend.py. All the backend related data will be in this file, and this is a front end file. All the related front end related data will be in this file. So this is a requirements.txt. Means whatever the requirements we need to do this project will be written in this file, and this is a .env file. Means whatever we want the API keys will be written in this file. So this is a document folder. In this folder, I have a file called example.txt. So this is the content I have in this file. Now, what I'm going to do is, um, whenever I ask the question in this file, it has to give me the reply from this content only. It should not give any hallucination data. So these are the files I have. And now I'm going to explain you all the code. So this is a backend file. So these are the importations I have taken in this backend file. This is OS. Uh, import OS means why it is used means to access the files, folders, or any API keys, whatever we have taken from .env, it will be accessed here. And this is a UUID, means a unique identifier, which will be given to the thread. And this is a JSON. All the data will be written in the JSON format. And this is a FIAS. FIAS means it is used as a vector store. Uh, it is a database I have taken for the vector store. And here we are taking the NumPy as NP, use it for numerical representation. And I am taking here .env. From .env, we are importing a load.env. So why we are taking this is to get the Gemini API keys from .env file. And this is a from sentence transformers, import sentence transformer. So why I'm taking this sentence transformer is to embedding, to embed the chunks into uh, numerical representation. For that to convert into embeddings, we are taking the sentence transformer. And from LangChain, Google Gen AI, import chart Google Generative AI. So why I'm using this is to access the API key, I need this importation. So this is all about importations. And now I'm loading this environment. So load.env means I'm loading this .env file. So here I'm getting Gemini API key equals to os dot get env of Gemini API key. So whatever the Gemini API key I have written in this .env, I can access here. I can get it here. So if not Gemini API key, means if I don't have any Gemini API key in this .env file, I have to raise the value error as set Gemini API key in .env file. And this is a LLM configuration. So here what LLM model I have taken here is a chart Google Generative AI of model is Gemini 2.5 Flash, and the Google API key is Gemini API key. So this is the LLM model I have taken, and this is all about database. So the database file name I have taken as local chart DB. So this is the one. This is a database file. In this database file, I have stored all the information like thread ID. In this thread ID, what questions I have asked and what responses I have got from the assistant. So what the user asked the question and what responses he got. So all this will be stored in this local chat DB database, means FIAS database. So this is a file name and FIAS index file. So this is the one FIAS index file. This name is as FIAS index dot index. So uh, all the indexes will be in this file, will be stored in this file. And this is a document folder. I have taken the document folder as a documents. So this is the documents. So here what I'm doing is I have taken a function as load conversation, and here I'm checking if the database file is exist or not. If it is exist, I'll open this file, and here I'm doing is a read mode, means I'm loading this data, and it is returning the data in the format of JSON. So here I have used with. Whenever I used it with, it automatically closes the file. If it has if I found a path, it will return as the DB file content. Otherwise, it will return me the empty dictionary. So this is the function of save conversations. So I am passing the DB into it. So here I'm opening this DB file, and here I'm taking the write mode. Whenever I use the write mode, I can save that conversation. So here I am using json.dump of dbf intent equals to 2. Here I am saving that conversation. So here I am loading the conversation, and here I am doing this save conversation. And here I am taking the generate thread ID function. uh, what happens here is it will return give the unique identity to each thread. It will return that thread as a string. So this is the embeddings. I have used the sentence transformer. From this sentence transformer, I have used this model, embedding model, all mini LM L6V2. So this is a free version. So that's why I have taken this, and I'm storing this method into model into the embedding model parameter variable. So here I have taken the function as a load documents. Here what I am doing is I am taking the doc folder as an argument. This is a one argument. If I don't give any argument here, it will take the default as docs folder. So initially we have docs metadata as a empty list. So here what I am doing is I am checking if the document folder is in current directory or not. If I found in this current directory, uh, I look into like if whatever the file names are there in this document, means I'm checking this document here, means if this document folder is in the current directory or not. If I have any if I found this, so I'll look what are the files list are there in this document folder. If I found many files, I'll loop those files whatever I want. I'll stop there. So here I'll get what file I want. So here I'll get the list of files in this folder, and here I'm joining that document and file name. So the output here, how I can get the output as like a document name. From documents folder, I'm joining the file name as I have taken as example.txt. So this is how the document folder and the file name will join. And here what I'm doing is I'm checking if the if the file path is there or not. If I found that file, here I'll open that file and I'm taking as a read mode. I'm reading that file. Here I have taken as encoding equals to UTF minus 8. So what is the use of this means? It is used to avoid the character errors. So here what I am doing is I am reading that file, means loading that file, and I am loading that file into the text variable here. So what happens here is all the content of the file will be stored in this text variable. So I am appending this text variable to this docs variable. So what actually docs here stores is the content of the file. So here what I'm doing is I'm appending the file name. So whatever the file name you are looping here in this list, that file name will be appended to this metadata. So actually what metadata will store here is the file name or the information of that file. So what it will return as is return docs comma metadata, means the content whatever we have, the content that will be written here, and the name of the file will be written. And this is Fire's vector store. Here I have taken a function as a built Fire's index. I'm taking the docs parameter. I'm passing this document, means whatever the content I have stored in this document, that will be passed here. And here what I am doing is by using this embedding model, I am converting this text, the text whatever I have in these documents, that will be converted into the numerical representation, means embeddings. So here I am taking convert to numpy equals to true. So by using this embedding model, I am doing this text into embeddings. So here what I am doing is for each word, we have an embedding like can. For word can, it has an embedding. For word the, it has an embedding. So each word has different embeddings. So what is the dimension of that embedding? Each embedding dimension will be taken here. So by default for this model, what I have used here, that is 768. So here what I am doing is I am doing the dimensions for each embeddings here, and I am passing these dimensions by using the index flat L2. I am creating the index here. So I am creating an index and I am adding these embeddings to the index. So next, what I'm doing here is Fayaz dot write index. Write index means I am saving these index into the Fayaz index file. So this file. So all the index will be saved into this file. And what I'm returning here is the index and the embeddings have done here, that will be written here. And the another function is load Fayaz index. So here we are building the index and we are loading that index. So to load the Fayaz index, I need that document text. So I am passing these documents into it. So here we'll check if the Fayaz index file is exist or not. If the file is exist, we'll read it. So Fayaz dot read index of Fayaz index file. So we'll read those indexes from the what indexes were there in Fayaz index file, that will be readed, means loaded into the index. And here what again we are doing the embeddings, means converting the document into the numerical representation, and I am returning that index and embeddings. If I don't found the path of the file, we'll rebuild the or we will build the index freshly by using those docs. So from a load document function, so this is a load document function. What I am returning is docs means the content of the file, and metadata means the name of the file or the information of the file that will be given to this. So whatever the content is there in docs, that will be stored here, and whatever the metadata file name, that will be stored here as a doc metadata. And from load fires index, so this is a function. From this function, what I am getting is I am passing is documents. What it is returning is index comma embeddings, so that index will be stored as a fires index, and these embeddings will be stored as a document index. Why? Because this is a embeddings of the document. So I also want embeddings for the user query also. So that's why I have taken as a doc embeddings. And then retrieving top key similar documents. So what about this is retrieving means whenever a user asks a query, that query will be changed or converted into the embeddings. So whatever the similar top modes similar will be uh, will get for the user question, that will it retrieve that content. Like, so I have taken here is a retrieve similar docs function. I'm passing a, if you want to get or retrieve anything, we need to give this user query. So query, and here I'm taking k as a 5. Why? Because, so what is this k means, it will return us how similar words means top matching words to our question. Like I have taken example, suppose my name is Sushmita, I am from Andhra Pradesh. So whenever I give the k equals to 5, it will return us the topmost answer to our question. So who is Sushmita? So I'll get some answer. If I give k value as 7, so it will return me as my name is Sushmita and I am from Andhra Pradesh. So whenever I'll increase this k value, it will return us the uh, similar values. So what it will do is it will take the query and it will encode means it will use the embedding model and it is converting that question into the numerical representation here. That will be stored as a question embeddings. Why? Because here this is a document embeddings. Whatever the content in the document, that will be embedded, and that will embedding will be stored in the document embeddings. Here the same as the above. User question is also converted into the embeddings. That question's embedding will be stored as a question embeddings. So from FIAS index, we are searching. What we are searching means question embeddings. It takes question embeddings and the top similar word, top matching words as K. So it will take the user embeddings and it will search in the FIAS index for matched embeddings from the document, matched embeddings with our question. So it will take that indices and it will store the store that position or the position of those matched embeddings or indices that will be stored in these indices and distances. So what indices means? Indexes means the position of the uh, indexes, sorry, position of the similar one what we got by using the search method, that will be stored here. And distances means how similar that word is to our question, that will be stored here. And then it will return as the like embeddings. So what I want is I want it in text, so that's why here what it will do is it will return as the text of that indices. So it will return as the text means the similar answer to our question. So it will return as those results. So here I have taken the chat drag function, and here what I am doing is I am taking a user question and passing the thread ID. Means thread ID means if we are starting any conversation, that is a thread, means chat history. So I'll give a ID for that, unique ID for that thread. So this is a thread ID. And by using this retrieve similar docs function, whatever it has taken user question k equals to 5 as a parameter, it will give us some top docs, means top matching answer to our question that will be stored here. And here what I'm doing is I'm doing this, I'm taking this top docs, whatever the tops answer we have got, that will be joined into this context text. Like in the double quotes, it will take this answer in a lines, like this is a line and this is a line slash, and it will take a not it won't take as a single string, it will take the answer in the multiple strings. So this is how I got retrieved the text. Means from RAG, as we know, RAG stands for retrieve, augmentation, generation. So till now, what I done is retrieve. I have passed the document, I have done the chunks, and I have done the convert that text into the embeddings. I have stored it in a vector store, and I have asked a question. That question also will be uh, embedded, and I have searched for top similar embeddings for our question with our question, and I got an output for that for the user question. So till now what I have done is retrieve. I have retrieved the context. Next what I have to do is augmentation. Augmentation means context plus whatever the context we have got, that context, and we have to provide a prompt like you are this, you have to do this. So this is a behavior we are setting, means you have to give the answer from the document only, and you don't need to hallucinate. So we are giving the instructions. That prompt, context plus prompt, means augmentation, means a from rag. So we have got the context, and we are building the prompt, means we are giving the prompt in the, this is a format string. Like what I'm saying is, you are an expert assistant, you use only the following document to answer the user question. So whenever the user asks a question, it should give the response from that document only, it should not hallucinate. So this is the user question, and this is a relevant document, means context what we got from the vector store. So this is how it will generate as the response. So this is the augmentation. So till here retrieve, and this is a augmentation. From RAG we have seen retrieve, augmentation. So what we want now is generation, means output generation. So here LLM dot invoke of prompt. So what I am doing here is uh, by using this invoke method, I am giving this prompt to the LLM. So that will be stored as a AI message variable, and whatever the content in this, that will be stored in a variable as response. So here I got the response from Gemini. It will take the context plus prompt, and it will give us the response. So here what I'm doing is db equals to load conversations. We are calling the load conversation function. So if thread ID is not in the database in the db, uh, if I don't find any thread ID, it will be empty list. So for this empty list, what I am doing is I am appending the role as user, content user question, and role assistant content response. So what does it mean is this is a role of user, and what the content the user question means, content means here whatever the user ask a question that will be stored here as the content, and the role is as a user. So this is a assistant. Like I'll show you one thing. So this is what. So this is a thread ID what we have given as a unique one. So in this thread ID, this is a role of user, and the content is what the user has asked. And this is a role of assistant. Content is what we got responses from the uh, LLM. So I'm saving the conversations, calling the save conversation function. So it will return us the response. This is how a RAG works. RAG means retrieval, augmentation, generation. We are doing, we are sending the text, and we are converting them into the embeddings, and we are storing it into the vector store, and we are asking a question. That question will be embedded, and that question will also embeddings will be stored in the vector store, and we are searching for the matching topmost matches with our question, and we are getting that as context, and we are giving the augmentation means we are giving the prompt plus context to the LLM, and we are getting response from the LLM. This is a RAG. This is all about the backend file, and this is a front end file. So what I'm importing is Streamlit, and from backend what I'm importing is chart track function, and generate thread ID function, and load conversation function. So if the thread ID is not in the session state, means if I don't find any thread ID, I'll generate a thread ID to this. I'll generate a thread ID means unique ID to the thread. Means here if chart threads not in session state, means chart thread means like chart history. If I don't find any chart in the session state, I'll load the conversation into these chart threads. Here dot keys means all the threads, and here what I'm doing is st dot session state of thread id. So we are giving the current thread id, means whenever I open the whenever I have started to ask a question or giving the input, so that thread will be stored as that will be called as a current thread. So if current thread is not in the session state of chart threads, so I'll append the current thread to that message history or chart history. So if I don't find any current thread, I'll append that current thread. So this is about the user interface we are giving. So header, my conversations, this is a name. And we are giving a button as new chart. Whenever we click a new chart will be open. And we are giving the unique thread ID to this thread ID, means we are generating a thread ID, and we are giving the thread ID to the current thread, and I'm appending the current thread to the chart threads, means chart history whatever we are doing now, that current thread will be assigned to this or added to that. And here what I'm doing is from session dot state of chart threads, I am looping for thread ID. So here we have a button as thread is thread colon. Here we'll get the thread ID as a unique identifier number we'll get here. That will be that we will see in the after execution. And here we are giving the thread ID to this thread ID. And for current thread ID, I am giving the thread ID. And here db equals to load conversations, and db dot get current thread ID, that means that will be stored into the history means the message history. We are giving the current thread ID. So for each message in history, we'll give the role and the content. Means it will mark down. Means it will show as a role content. So this is how it looks. Role content. For user, it will take role as user content. For assistant, it will take role as assistant. It will give us the content. So it will show us as a role content. And here what I'm doing is I'm taking the input as enter your question here. So user input, user will ask a question here. So if user input start st.chat message of user, it will give us the user question. Whatever the user has given the input, that will be uh, shows us here. The input question will be as text. And the chat track, by using the chat track function from backend file, you're taking the input, user input and current thread ID for that answer. So this is how it looks. Means it will give us the assistant role. Like, so this is how role assistant and the content what I am getting from that LLM. So this is the front end of the file. And the requirements Streamlit for user interface and Fires for database vector store. And this is LangChain, Google Gemini, and Sentence Transformer for embedding, and Python.env for getting the API key from the .env file. And this is the virtual environment I have created. And this is the folders I have. Now I'll show you the execution. Now I'm opening the terminal. Now I've activated the virtual environment and I'm running the Streamlit. Oh, it is taking time to load. So it is loading. So as I taken the subheader as a my conversation in front end, so this is how it will give as my conversation. Like, and this is a button what we have taken as a new chart. And these are the thread IDs. So these are the thread IDs. Previously I have used. It will store as a thread and the unique ID to this. And this is another thread, means another conversation or another message history. And this is the ID for this. And if I click this, the previous chart will be open here. And if I click this thread, the conversation we had in this thread will be shown here. And these are the threads we have conversations. So these are the thread IDs I have used before. So current thread means, so whatever I'm doing whatever the thread I have used here is this is the current thread now. So we can ask a question. So what file I have taken here is, so this is all about artificial intelligence, machine learning, deep learning, applications of AI. So we'll ask a question like, what is an AI? So this is the input where the user can give what is AI. So this is the role of user, means what the user content I have given. So this is the response I got from the LLM. So artificial intelligence refers to the development. So this is all I have taken in this file. So this is the file I have taken. So all the information it will give to me, whatever I have taken from that file. So if I ask any non-related data, like what is the weather today? So it is saying me like, I'm sorry, but the provided document, it will discuss about artificial intelligence, machine learning, deep learning, NLP, and their applications. They do not contain any information about current weather conditions. So if I ask any out of the document questions, it won't give us the reply by hallucination. So whenever I ask the question from the document only, it will give me the output. So this is how the RAG works here. RAG means fetching the data from our data only, means fetching from our data only, not by any LLM or any other content. So this is about RAG implementation. So thank you.